In today's world, which is increasingly plagued by wildfires, understanding and combating these natural disasters is of crucial importance. This is where Roshan comes into play, a simulation tool for vegetation fires that is based on a combination of cellular automata and reinforcement learning. Roshan, standing for Rescue-Oriented Simulation, Handling and Navigating Fires, aims to simulate the dynamics of wildfire spread and develop effective fighting strategies. Utilizing the Korean LandCover database, Roshan generates realistic landscape models and provides an interactive interface that allows users to observe and control fires in real time. A unique feature of Roshan is the use of an agent trained through reinforcement learning that is trained to identify and extinguish fires. The integration of maps is done directly via OpenStreetMap, accessible through a menu within Roshan. Users simply mark the desired area on the map, after which the data can be directly loaded into the simulation. This data can also be saved and later reloaded to test different scenarios or strategies. The simulation integrates 11 distinct terrain classifications, each reflecting unique landscape characteristics derived from the Korean LandCover database. These classifications are essential in defining the model's environmental parameters, closely aligning with the respective fuel types found in different regions. The heart of Roshan is a fire spread model named FireSpin. It is based on cellular automata, systems that simulate complex phenomena through simple rules and local interactions. Unlike traditional models, in Roshan, each cell generates virtual particles that move across a terrain and can ignite further cells. The model differentiates between two types of particles: radiation particles, which spread in a circular pattern around the cell, and convection particles, which are primarily dispersed by the wind. The quantity and type of particles released by a cell are determined by its terrain class. These classes also regulate the ignition speed and the duration until a cell is completely burned out. As we have seen, terrains such as forests and grasslands are represented with unique characteristics. Forests, depicted in deep green, have a longer duration to fully burn and require more time to catch fire, reflecting their dense and moist composition. They spread fire mainly through the air, mirroring the real-world behavior of tree canopy fires. Grasslands, shown in light tan, catch fire more quickly and burn rapidly, consistent with the behavior of dry, less dense vegetation. Though they spread fire less through the air, the heat from grassland fires can still ignite nearby areas. At the core of Roshan's approach to wildfire management is the incorporation of a reinforcement learning agent, represented by a drone. This agent plays an important role in the system, offering a method to not only detect but also counteract the spread of fires within the simulation's environment. Using the principles of reinforcement learning, the agent continuously learns and adapts from its interactions with the simulated wildfires, aiming to optimize its strategies for fire detection and suppression. The agent in Roshan operates based on a reward system, where actions leading to successful fire detection and extinguishment are positively reinforced. Through repeated cycles of observation, action, and feedback, the agent refines its understanding of the simulated environment and improves its decision-making process. The agent's interaction with the environment is characterized by a twofold objective: to identify and extinguish fires. The agent receives input from the simulation in form of terrain, fire status, and its own position and velocity, which is used to calculate the most efficient path towards fire zones. It has the capability to release fire retardants once it arrives at a target location, simulating the process of extinguishing a fire. To conclude our exploration of Roshan, we want to highlight that the development of the reinforcement learning agent is an ongoing process, currently being advanced through a master thesis. This effort is focused on enhancement of the agent's capabilities. We also want to point out that Roshan and its related developments are available as a project on GitHub. Thank you for your attention and interest in the project. Stay curious, engaged, and safe.